Okay, in this video, we are going to do something a little bit different. As you can see, we have these integrals on the board, but we are not going to solve them. Instead, we'll just talk about what technique shall we use for these integrations. Well, this right here is meant to be for Cal 2 students. So, of course, you have to know the integration by parts, trig sub, u sub, and also partial fractions, and the trig integrals, identities, and all that. And I have this file for you guys. In fact, we have a total of 12 integrals in this video. You guys can download this. The link will be in the description. Of course, it's free, right? So if you guys like this, just give me a like and share this video with your classmates, your teachers, your students. I will be really grateful. Thank you guys so much. Okay, so let's get started with the first one, the integral of natural log of x over x to the third power. First of all, u sub is not going to work. Let's see. I have pretty much two functions. The first one is natural log of x, and then the second one is 1 over x to the third power. I know how to integrate 1 over x to the third power. I know how to differentiate natural log of x. So in this case, let's go ahead and do this by integration by parts. And the truth is, whenever you have the integral of x to some power times natural log of x, you can do them by integration by parts. And of course, you can set this up by the DI setup, the DI method. This is just integration by parts. This is like saying the u, this is like saying the dv, right? But I have another video in the discussion on that, but this is just the first step. All right, let me differentiate natural log of x, because if you want to integrate natural log of x, you have to use integration by parts again, so don't. And then I will be integrating 1 over x to the third power. Of course, this is the same as x to the negative 3. So this is like saying x to the negative 3 times natural log of x. Use integration by parts for this. And then remember, differentiating this, you get 1 over x. Integrating this, add 1, which is going to be negative 2, and then divided by that new power. So we end up with negative 1 over 2, x squared in the denominator. And then remember, the product of this diagonal is the first part of the answer. And then the product of this row, you still have to put in the integral. And then when you do this times that, in fact, you can integrate that. So that's the idea. And now let's talk about the next one, the integral of secant to the fourth power of x. First of all, you should know some famous ones as well. If you have secant to the third power, you have to do that by integration by parts. When you have secant to the fourth power, this is actually much easier. You can just do some trig identities. So I will write this down for you. I will actually take out 2 of the secant. So we have secant square x right here, and then times secant square x right here, and then dx, of course. And then from here, I can write secant square x in terms of tangent. So this is going to give me the integral. This is in fact the same as tangent square x plus 1, like this, and then times secant square x dx. After this, what do? Yes, we can just do a u sub right here. So I'll write this down for you guys. You take u to be tangent to the first power x, and then you see du will be secant square x dx. And then you can take this integral to the u world, and then you finish it over there. You can be a calculus finisher as well, right? Now, let's take a look at number 3. 2x plus 3 over x squared minus 5x plus 4. First of all, the derivative of the bottom is 2x minus 5. It's not exactly the same as the top, right? Unfortunately, u sub doesn't work. This is the rational function. On the bottom, we can factor it, so we will just factor this, and we can do partial fraction. And when you factor this, you get x minus 1 times x minus 4. And as you can see, we have 2 different linear factors. That means we can just do the partial fractions by the cover-up method. So I'll write this down right here for you guys. This is the integral. And then the first fraction has x minus 1 as its denominator. And then the second one has x minus 4 as its denominator. To figure this out, this is just going to be a number. You can put down a if you would like for now. And then this is a b. Now, to figure this out, you go back to the original. You cover the same denominator, which is x minus 1. And you have to ask yourself, how can you make x minus 1 to be equal to 0? Well, x has to be 1. Then you plug in 1 into the rest of the x. On the top, Let's do this on your head, okay? 2 times 1 is 2 plus 3 is 5. On the bottom, 1 minus 3 is negative 3. So what does this mean? We end up with 5 over negative 3. That's for A, negative 5 over 3, right? Now, let's do this B right here, x minus 4 for this denominator. Go by there, cover this up, and you have to plug in x equal to 4 here and here. On the top, 4 times 2, 2 times 4, same thing. 8 plus 3 is 11, divided by 4 minus 1, which is 3. So 11 over 3. So B is 11 over 3, like this. And then from there, you can just integrate this fraction and that fraction. And because this is just x to the first power, you end up with the natural log, right? But I'll leave that to you. Now let's take a look right here. The integral of x squared times tangent of x to the third power. What do we do? Take a look of the inside. X cubed. When you differentiate x cubed, you get 3x squared. We do have the x squared on the outside that can help us out. So we can just do this by u sub. Let u equal to x cubed. And then from there, we get du equal to 3x squared dx. And if you want to isolate the x, I think that will be easier. Let's divide this on both sides. We get dx equals du over 3x squared. Put this in the u world, and as you can see, the x squared will cancel out. You will have 1/3 factor. And you will have to know how to integrate tangent of u. So let me just make a note right here for you guys. You also have to remember that the integral of tangent, and let me just put down u for this for you guys. This right here is equal to the natural log absolute value of secant of u and then plus c, right? You have to know this so that later on you can just use this. And of course, to integrate this, you can write this as sine over cosine and then do another substitution. But you use u already, so you can use w and all that. And you do have the 1/3 factor, but I'm not working that out. That's your job, right? So you have to remember this so you can finish that. Now let's take a look at this. We have the integral of 1 over 1 plus x squared, and then to the 5 over 2 power. Well, this is so intimidating. But inside here we have two terms, 1 plus x squared, and we have to know that. It's just like this. Look at that. 1 plus tangent squared. This right here is equal to secant squared. It's just one term. You can put this right here. Yes, we'll just do a trig sub for this one. So when you have a number square plus x squared, we'll take x to be tangent. You let this x to be tangent, take x to be tangent, and we take this to the theta world. And you really have to do trig sub here because on the top it's just a 1. If you have x, you can just do a regular u sub, right? You can just let u equal to this. But unfortunately, we don't have that. Take x to be tangent theta, and don't forget dx is equal to secant squared theta d theta. You have to remember to put this back for dx. And then you also have to know that when you have 1 plus tangent squared theta, this gives you secant squared theta. Yes, it's kind of weird because the derivative of this is secant squared. And then 1 plus tangent squared is also secant squared. But this is a trig identity. This is the calculus derivative right here, right? So now let's take a look at the integral of e to the square root of x. This right here seems kind of impossible, right? But the truth is, if we take this integral to the u world, you will see what we need to do. So let's make that happen. I will first let u equal to this, namely square root of x. And then before you differentiate both sides, well, let me just square both sides so I can get x equals to u squared. Because this way, I can just look at this and differentiate both sides. I get dx that's equal to 2u du. And then I can just take this integral to the u world, and then you will see that we will have the integral of e. This is my u now, and then times the dx is 2u du, like this. And then as you can see here, we have 2u to the first power times e to the u. And yes, in this case, you can just do di method, namely integration by parts. So you're going to do the di setup right here. And in this case, we can actually finish the derivative. So I'll put on 2u right here, and then we'll integrate e to the u. And then differentiating 2u, you get 2. Differentiating 2, you get 0. So you stop, right? That's the first stop when you see the 0 in the d column. And as you can see, when you integrate e to the u, you always get e to the u. So this is pretty much it. And then, of course, the product of the diagonals along with the sign in front, they will be the answer. However, once you finish that, be sure you go back to the x world. And of course, I will leave that to you guys. And now, let's take a look of the other questions right here. Okay, number 7, integrating sine square x. Well, in this case, as you can see, we don't have cosine x to help us out. So don't do u sub yet. In this case, we have to actually use the identity to reduce the power. When we have sine square x, we know this right here is equal to 1/2, which is the constant multiple. We can take that to the front of the integration. And then the integral, again, this is equal to 1/2 times 1 minus cosine of 2x, like this. And you have the dx. And then right here, you can just go ahead and integrate. Integrating 1 in the x world and also integrating this in the x world. And right here, you have to do a u sub, but I will leave that to you guys. Now, number 8, the integral of 1 over square root of x plus 1 minus square root of x. In this case, I don't think u sub can help us out. Of 2 square roots, I don't think u sub can work this out nicely for us. It maybe works, I don't know. But I know that maybe I can get rid of the square roots in the denominator, just like the good old days, right? We can multiply the bottom and the top by the conjugate, so we can say bye-bye to the square root in the denominator. So let's do that. Let's multiply the bottom by square root of x plus 1 and change the minus to a plus, and then you have the square root of x. And of course, do the same on the top, square root of x plus 1 plus square root of x. And the beauty of this is that when you multiply this and that, remember, we end up with this thing squared, which is just x plus 1, and then minus this square, which is just x. And you see, x minus x is just gone. And then, of course, we have the plus 1, and you have this over 1. Of course, the over 1 doesn't matter. In another word, we are just integrating square root of x plus 1, and then plus square root of x, like this. And then put down the dx right here. And you can put parentheses right here. Be sure you just integrate this, and maybe you can do a little bit u substitution. But the inside here is just x to the first power plus 1. The derivative of this is just 1. So if you let u equal to x plus 1, you just get, du to be dx. So you can just go from there, right? So put down this right here for you guys. On the exams, do not put on ... okay? You actually have to do all the work and then show me the final answer, right? Anyway, number 9. Oh my god, this looks crazy. We have e to the x over secant x. But don't forget that secant x in the denominator is the same as what? It's just the same as cosine x. So in fact, this integral is the same as integrating e to the x times cosine x. And do we recognize how to integrate this? Sure we do. How do we do it? Yes, integration by parts. And this right here is a famous situation that you are going to get a repeating situation, right? So let me just put this down right here for you guys. D and I need 3 of them. Okay? And in fact, it doesn't really matter which one you pick to be integrated. They're equally easy. You can integrate cosine, you can integrate e to the x, doesn't matter, right? But let me just go ahead and differentiate e to the x and then integrate cosine x. And you may be saying, maybe you want to integrate e to the x, it's easier. That's up to you. This is just as fine. Anyway, you get e to the x after you differentiate this, and then integrating cosine x. First, you get positive sine x. And then integrate this again, you get negative cosine x. Look at the function part. E to the x and then cosine x. This and that repeats, right? This right here, repeat. So remember, you multiply this and that along with the sign in the front. This is the first part of your answer, and then this and that. That's the second part of your answer. Don't forget this right here, when you multiply, you still have an integral. And then you're going to write this down in a line, and you will see you have to add this on both sides, and you will have to take care of that. It's a repeating situation, right? Okay, now let's look at number 10. We have the integral of 1 over 1 plus cosine x. Again, I don't have sine x to help me out. What do I do? Well, this right here, I don't like it. What I like is 1 minus cosine square, because that's the same as sine square x, right? Well, it's okay. Let me just go ahead and multiply the bottom and the top by the conjugate. It's similar to that. It's going to work out nicely. Let's do it like 1 minus cosine x on the bottom and also on the top. And you will see that this is the same as the top is just this, which is 1 minus cosine x, and on the bottom, when you multiply this out, you get 1 minus cosine square. In another word, we get sine square x. And now we have more things to work with. This is pretty straightforward now because we can just split the fraction since we only have one term in the denominator. First, integral is the integral of 1 over sine square x. And then perhaps let me close this, and then I will put down the minus, and then the integral, and then we have the cosine x over sine square x. And let me write this down as sine x times sine x. For a good purpose, you'll see. This right here, you just have to focus on integrating cosecant square x. And you have to know your derivative really well for this one, right? 1 over sine is cosecant, 1 over sine square is this. So in fact, this is pretty easy now. But for this one, look at, I have this over that. This is like same 1 times cosine over sine x. So you can say this is minus the integral. 1 over sine is cosecant x, and then cosine x over sine x is cotangent x dx. And again, if you recognize this is the derivative of some function, then you can integrate that. But again, I will leave this to you guys. Or right here, you could have done u sub as well. That's fine. But once you put this down in this form, you can just recognize this by knowing the derivative of some function is equal to this, which is very nice. Okay, 2 more, right? And once again, let me know if you guys like this one or not. If you guys do, maybe I'll produce part 2, like the other ones for you guys. Okay, number 11, x minus 4 over x to the 4th power minus 1. The derivative of the bottom, it's not the same as the top. Partial fractions then, right? So let's factor the denominator. This right here, look at this as the difference of 2 squares first. X squared square minus 1 square. So first you can factor this as x squared minus 1 times x squared plus 1, right? And then this is still factorable. You can factor this to be x minus 1 times x plus 1, but this is no longer factorable. You keep it. This is a irreducible quadratic, right? And then the general form for this situation is that, well, first of all, you have this for its denominator. So I'll put down x plus 1. Well, the first one I put down is negative, so I'll put on minus here. Anyway, this is linear. That means the top has to be just a constant. And then next, I have another linear factor. This is different than that. So I put down x plus 1, and it has to be a constant on the top. Next one, we have x squared plus 1. This is irreducible quadratic. So I will write down x squared plus 1, but the top has to be 1 degree less than this. Namely, it has to be a linear now. So I will put down cx plus d, a, b, c, d, all that. And then, of course, you're going to find out the a, b, c, d, and then integrate them, right? So I'll leave that to you guys. Okay, for this one right here, don't erase the x squared on the top and just say, hey, I want to have the x on the top. That would be so easy. You can just do u sub for this situation, right? But you do have to handle this x squared. Here we have square root. So this is not partial fraction situation. And technically, this is just one term, the square root term. So you don't do the conjugate like that. Well, in the square root, we have 1 minus x squared. It has two terms. Yes, we can do trig sub for this. And we have to know that 1 minus sine squared will give us cosine squared. You can also use this 1 minus cosine squared to be sine squared, but just take this x to be sine theta, right? But of course, you have to change that to the theta world. So let x equal to sine theta. That's the deal. And then don't forget to change the dx. So I will have to differentiate this on both sides. So I will get dx to be the derivative of sine theta. You are doing the derivative right here, okay? Not integral. So from here to here, it's just the derivative. You get cosine theta d theta. And that's pretty much it. But I think I'll work this out for you guys have some more space. Why not? Here we have the integral. On the top, I have sine, right? That's x, and then you square that, so we have sine squared theta. On the bottom here, we have square root. And then we have 1 minus sine squared again. So we have sine squared theta. Here is a super common mistake. People don't like to put down a d whatever. This right here, if you don't put down anything, that's like driving without your seatbelt on. Very dangerous. So don't do that. Remember, dx, you did the hard work. So put it down. This right here is cosine theta d theta. Okay? And now we'll clean things up. Right here in the denominator, I just focus on this square root part. 1 minus sine squared is cosine squared theta by the square root. After you cancel out the square and the square root, don't worry about the absolute value. Just focus on cosine theta because you just want to focus on integration. And check this out. Cosine theta and cosine theta cancel each other out nicely. And how can we integrate sine squared theta? Yes, we do this again, right? So I will leave the rest to you guys. All right, so this is it. Hopefully you guys all find this video to be helpful. And if you guys are in Cal 2, best of luck to you guys. Have a wonderful semester. Know your integrations. Integrations are a lot of fun. Anyway, this is it.